So the question given, decide among the following sets which sets are subset of one and another. Here given a set is x belongs to R, a real number, x satisfy x square minus 8x plus 12, x square minus 8x plus 12 equal to 0. If we solve that, this will be like x square minus 2x minus 6x plus 12 equal to 0, which will result in 2 and 6. So we get the set A is 2, 6. So here given B is 2, 4, 6, C is set of all even numbers, even natural numbers, and D is 6. So what we can say, D, the smallest set only containing the element 6, is the subset of A. A contains 2 and 6, which is subset of B. It contains 2, 4, 6. Extra element is 4. So it also, B is also a subset of C. Why? It contains 2, 4, 6 and all other even natural numbers. So we get this. If we write individually, then the answer will be A is subset of B, A is subset of C, and B is subset of C, and for D, D is subset of A, D is subset of B, and D is subset of C. This is the answer. The next question is, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. Now the first question is, if x belongs to A and A belongs to B, then x belongs to B. So we are taking an example first. Okay, let us consider, let 2 belongs to A. Okay, so and we are considering the set A as 1, 2, 3. So this will satisfy 2 belongs to A. Now there will be a set, we are satisfying this portion first. Okay, so the B will be like we are considering like 0, 1, the set 1, 2, 3, the set 3, 4. Okay, now here 2 belongs to A. Yes, 2 belongs to A. A belongs to B. Yes, it's satisfied that this set is belongs to B. Okay, this set is belongs to B. So A belongs to B is also satisfied. But you can see 2 does not belongs to B. There is no element 2 in this set. It's in the set, but it's a combination of elements. Okay, so 2 doesn't belongs to B. So if we can prove it for one example that it is false, the statement will be false. So next problem is, if A is subset of B and B belongs to C, then A is subset of C. A belongs to C. We have to show that A belongs to C. So we are considering A as a set 1, 2, and B is 1, 2, and 3. Okay, so A is subset of B is satisfied from this example. Now it's written that B belongs to C. So C set will be considered as let us assume 0, 1, 2, 3, and 7. This is the set C, and here B is belongs to C. This element is actually B, so B belongs to C. This statement is also satisfied, both the statement. Now we see that 1, 2, the set is not present in C. Okay, 1, 2, 3, the combination of elements, the set 1, 2, 3 is present, but 1, 2 is not present. So we can write A does not belongs to C. Okay, so the statement is false. Now the next question is given, if A is subset of B and B is subset of C, then A is subset of C. Let us consider A as 1, 2, and B is A is subset of B, so B will be like this. So the condition is satisfied. Okay, A is subset of B, 1, 2 is the element of B, 1 and 2 are elements in the B, and C will be superset of B, that is B is subset of C. That means we have to satisfy this condition also. The two conditions are satisfied. A is subset of B and C is, we are taking 1, 2, 3, 4. So B is subset of C. Now we can clearly see that A is subset of C. Okay, but this is just an example. Okay, we cannot conclude from the example that the statement is true. Why? If it is true, prove it. We have to prove that. For false statement, we can show any one example that is false. For true statement, we just can show only a single example. We have to prove it for general. So we will be proving it from the definition. What is the definition of subset? First, let x belongs to A. If A is subset of B, what will be the definition? X belongs to B. If X belongs to A, it will imply X belongs to B as A is subset of B. Any element of X will be an element of B. Okay. Now what? X belongs to B implies X belongs to C as B is subset of C by definition. Okay. Now what we can see, since X belongs to A implies X belongs to C, we can write A subset of C. For any general term X, we proved that the X, if X will belong to A, X will belong to C. Then by definition A is subset of C. We can write by definition. This is the proof statement. This is proved. Okay. This statement has been proved. Okay. Now what is our next question? If A is subset of B and B is subset if A is not a subset of B and B is not a subset of C, then we have to show that whether we have to check whether A is not a subset of C or not. Okay, so we consider A as a set 1, 2, B as a set suppose 8, 9, 10. So clearly A is not subset of B, we can see from here, and C we are taking 1, 2, 3, 4. Okay, so here also B is not a subset of C. Okay, but you can clearly see is A is subset of C. 1, 2 is present here, so A is subset of C. So we have to only show one example is not true for false statements. So this statement will be false. So the next question, if X belongs to A and A is not a subset of B, then X belongs to B. We have to check the statement is true or false. So let us consider A as 1, 2, the set, and B as 7, 8, 9. Okay, this is a set B. Okay, so clearly 2 belongs to A and 2 is an element of A, and B is a set. If this condition also satisfies, A is not a subset of B, and we can see that 2 does not belongs to B. Neither does 1 does not belongs to B. Neither 1 nor 2 is the element of B. So the statement is false. Okay. So our next question is, if A is a subset of B and X does not belongs to B, then X does not belongs to A. Let us consider an example. A is 1, 2, B is 1, 2, 3. Now 5, an element does not belongs to B. Okay, and 5 does not belongs to A. It seems it's a true statement, but if it is true, we have to prove it. Okay, now the no element in the set B, 5 is not an element in the set B, and 5 is not an element in the set A. This is an example. Okay, now so how we will prove that? Let X belongs to A. Okay, we are considering X is an element of the set A. Now as A is subset of B, as A is subset of B, which implies what? X belongs to B. Why? If X belongs to A and A is subset of B, by definition it will be an element of B. It is by definition. By definition X will be an element of B, but X does not belongs to B. So this is a contradiction. This is a contradiction. You have to write this is a contradiction because of this statement. So what we have assumed that is incorrect. Therefore we can write X does not belongs to A, and this statement is true. First we have to consider X is belonging to the set A. We have to contradict this first. Then as A is subset of B, X will be an element of B because of the definition. As per definition, if X belongs to A, then X will be an element of B if A is subset of B. But it's given in the statement X does not belongs to B. So this is a contradictory statement. So X will not be an element of A. Our next question is, let A, B, C be the set such that A union B is equal to A union C and A intersection B is equal to A intersection C, so that B is equal to C. So let us consider first X belongs to B. Okay, X is an element of B. As X belongs to B, we can say that we can imply that X belongs to A union B. Since B is a subset of A union B, we can write by definition X is an element of A union B. Now X belongs to A union C also. Why? Since given A union B equal to A union C, we are just changing in place of A union B, we are writing A union C. Now what does that mean? It means X belongs to A or X belongs to C. Okay, so case 1, we are writing case 1. Case 1 is X belongs to A, X belongs to A, and what we know that X belongs to B. This is we considered, so we know X belongs to B and we have X belongs to A. What does that mean? It means X is element of A intersection B. X belongs to A and X belongs to B means X is element of A intersection B, common element. Now X is an element of A intersection B means X is an element of A intersection C. Why? A intersection B is equal to A intersection C. Okay, now what does that mean? It means X belongs to A and X belongs to C. So we started with X belongs to A, B, and we ended with X belongs to C. X belongs to B implies X belongs to C from the case 1. And from case 2, what is case 2? Case 2 is X belongs to B means X implies X belongs to C. From the case 2 we got similar result, same result actually, similar not. And what does then, what we can say, if X belongs to B implies X belongs to C, then B is subset of C. In the case 2 we also get B is subset of C. Similarly, if we consider the same, just like that, X belongs to C, and we do the same procedure like X belongs to A union C, that is X belongs to A union B, X belongs to A, or X belongs to B. So if we start from that point of view, instead of going from X belongs to B, we will get same result, that is X belongs to C implies X belongs to B. From case 2 and case 1 both. Okay, with similar results we can get C belongs to C subset of B. And so we can write that similarly, considering X belongs to C, we can show that C is subset of B. So B is subset of C and C is subset of B implies B equal to C. You can check that by considering this, the case 1 X belongs to A. Doing the same, just this will be opposite, it will be A intersection B, A intersection C, this will be A intersection B because they are equal. That will give us X belongs to A and X belongs to B, and then if X belongs to C implies X belongs to B, we will get this. So this will be the proof.